Assalamualaikum warahmatullahi wabarakatuh. Hi all, I'm glad to see you. I hope all of you are well. In this presentation, we will discuss about isolation of steroid compounds from Hydrilla verticillata by maceration method. But before that, I will introduce my group. I'm Irma Afriani, and my friends are Febi Andriani, Santi Maghfiroh, Siti Amanatus S, Fitria, Maulidiah, Ivvani, Aulia, Putri, Atiqotul, Mir'ah, and Ulvi Dwi Pertiwi. Okay guys, let's check it out. Our general outline in this presentation are: first, background; second, aim; third, methodology; fourth, result; and fifth, conclusion. First, background. Hydrilla verticillata. Hydrilla verticillata belongs to the kingdom plantae and family Hydrilla. Hydrilla verticillata has belongs to the pro-activated component to the of up to 2 meters. The stem is slender and upright. The stem grows 1 to 2 centimeters in height with 2 to 8 leaves growing at the circumference of the stem. The leaves are serrated or small spines along the tips of the leaves. Hydrilla verticillata plants containing chemical compounds in the form of flavonoid, saponin, terpenoid, and steroid. Based on research conducted by Kinsa and Nela Megan 2015, the rate of screening for Hydrilla verticillata plants containing flavonoid, liquid, saponin, and steroid compound. Steroid. Steroids are included in a fatty compound that have a basic structure consisting of 17 carbon atoms that form 3 cyclohexane ring and 1 cyclopentane ring. The grouping is based on the group attached to the basic formwork of the carbon chain. Derivatives of steroid compound are cholesterol, ergosterol, progesterol, and estrogen. Based on the source, steroid compound can be divided into 3, namely phytosterol, defined zoolesterol from animal, and microsterol from fungi. In animals, steroid compound can be derived from insect and vertebrate animals. Steroid in plant are usually present in the form of sterols. Higher plant usually contain phytosterol such as beta-sterol, lignosterol, and cholesterol. Scientists have conducted research, namely isolating steroid compound from the kidney plant Adenomycus manifold and obtaining a steroid compound in the form of beta-sterol. Second aim. Formulation of the problem. First, how is the result of isolation and separation of steroid compounds using preparative single-layer chromatography? Second, how are the results of characterization of steroid compounds using UV-Vis, FTIR, and LCMS spectrophotometer? Third, methodology. In the research methodology, there are 8 stages to isolate steroid compounds from Hydrilla verticillata. The first is sample preparation. As a result, is 950 grams of dry hydrilla powder and then extracted by maceration method using 96 methanol resulted 5,14% yield. The concentrated methanol extract was hydrolyzed by adding 2 molarity of hydrochloric acid and partitioned using an hexane resulted 47,95%. The partitioned and hexane fraction was tested for phytochemical to obtain isolates and then separated by preparative TLC resulted 19 spots, whereas the steroid compound is on the 16th spot. After obtaining the steroid isolates, then characterization is carried out by UV-Vis, FTIR, and LCMS. Characterization using UV-Vis resulted maximum wavelength at 203,9 nanometer and 276 nanometer. And then characterization using FTIR suspected steroid compounds like alcohol groups, geminal dimethyl, ester, aromatic, secondary alcohol, and alkenes. And the last is characterization using LCMS showed the presence of steroid beta-sitosterol. The first step is sample preparation. Steps of sample preparation are: first, weights and grab of Hydrilla verticillata and wash it with water to clean the dirt. Second, dry it in dry sunlight or even heat to avoid damage to the active compound in the sample due to high temperature. The drying process is carried out because the Hydrilla verticillata plants still contain water. In addition, drying also functions to reduce enzymatic reaction and the growth of fungal pathway in sample. The third, mix the dry sample and dip it with a 90 massive. The function of dipping is to uniform the size as well as refinement to increase the surface area. Then the last, the fine sample were dried at 38 degrees Celsius for 24 hours to maximize sample drying. Second is sample extraction. The steps of sample extraction are: first, the extract of Hydrilla verticillata sample were weighed and put in thermometer. Second, soak in 300 ml of methanol and taken with a shaker of 3 hours. The dipping is carried out to step up the contact of the solvent with the sample so that the extraction process runs faster. Third, filter using a vaginal funnel to accelerate the separation of the residue and the filtrate. Fourth, pre-macerate the residue 3 times to optimize maceration. And then next step is filtered and combine the result of the three maturation. Next, evaporate and concentrate with a rotary evaporator at a temperature of 40 until 50 degrees Celsius, because methanol can evaporate below its boiling point in the presence of a pressure drop in the system. And then next is weigh the concentrate methanol extract, and the last step is the yield of the extract was calculated in order to obtain a concentrate extract of 5.14%.
And the next method is hydrolysis and partition. Hydrolysis and concentrated methanol extract partition. The steps are concentrated methanol extract added with hydrochloric acid 2 molar. The hydrolysis process is carried out for 1 hour and homogenized with a magnetic spiral at room temperature. Hydrolysis added saturated sodium bicarbonate to 7 pH or neutral pH. The hydrolysis results in partition with 25 ml and hexane in a skirting funnel, and all to stand until 2 layers are formed. Then, the water and organic layer is separated. The organic layer is taken to concentrated with a vacuum rotary evaporator and separated with M2 gas, which can calculate the yield value of concentrated extract. The next step is phytochemical test. The next step is phytochemical steroid test for methanol extract. The process are each sample for methanol extract and injection fraction was put into a test tube, dissolved in 0.5 ml chloroform and 0.5 ml acetic acid and dissolved. The mixture is then added to 1 until 2 ml of sulfuric acid into tube 1. Observe the color form. If a bluish green is found, it indicates the presence of steroid in the sample. The next method is separation using preparative TLC or thin layer chromatography. The step in separation of steroid compounds by preparative thin layer chromatography or TLC, there are first, the concentrated extract of the n-hexane fraction was placed on a 10 by 20 cm GF 254 silica gel plate with a distance of 1 cm from the bottom line and the outline, and then eluted using the elution n-hexane divided ethyl acetate for divided 1 and terminate elution once the mobile phase reach the margins. The stain of separation result then observed using UV light at wavelength of 366 nanometers. The result of stain that suspect of being a steroid compound was scraped off and dissolved with 5 milliliters of n-hexane. And then the solution is centrifuged to precipitate silica. The next method is characterization of steroid compounds. The steroid compounds in the n-hexane fraction were characterized using UV visible, FTIR, and liquid chromatography mass spectrometry instrumentation. First characterization of steroid compound is using UV visible spectrophotometer. The isolate from preparative TLC that were suspect of being steroid compound were analyzed using a UV visible spectrophotometer in the 200 until 800 nanometers wavelength range, and the reference used was n-hexane solvent. Second, characterization using FTIR. The result of the n-hexane steroid isolate were identified using FTIR through the preparation of the KBr pellet method. In this case, the crude extract that was crushed together with KBr was pressed with a pressure of 80 for 10 minutes to form pellets, and the pellets were analyzed using FTIR. And the third characterization is using LC-MS-MS. Steroid compound isolate were injected into the LC-MS-MS instrument H-mass S 2 microliters with the stationary phase, or the column used was high-pressure code, and the mobile phase was 0.1% formic acid and water, namely phase A, and 0.1% formic acid and acetonitrile, namely phase B. In this practicum, using 3 instruments. 1. Instrument function UPVs. Knowing the absorption peak can be used to measure the sample. 2. Knowing the absorbance and concentration relationship used for qualitative analysis. Qualitative analysis is based on the specificity of UPV spectroscopy. Sample absorbs light of one or more distinct wavelengths with specific maximum absorbance values. For this reason, each sample has a characteristic and unique UPV spectrum that can be used for its identification. In particular, this is as if by comparing the spectrum of the sample with spectra of node.
pure compound. 3. Knowing the peak of the spectrum, giving information about the structure of the molecule. For example, specific functional group of a molecular structure, such as carbon, oxygen, or C11O, absorb at specific characteristic wavelengths. 4. Provide information of the physical properties of the sample, and last, provide information on sample purity. 2. FCIR instrument function, identification of functional group and compound contained in the sample. 2. Identify the mixture of compound present in the sample. 3. Identification species and their structure. 4. Knowing the spatial absorption of functional group present in the sample. So in the FCIR instrument, you will get a spectra that shows the molecular structure of the particular absorption. Instrument function of LCMS. 1. Separating mixture based on polarity. 2. Detect charged ions in order to obtain the molecular weight, structure, identity, and quantity of certain sample components. On this instrument, the specific weight will be known, like the steroid that has a beta-sterol compound.
4th is conclusion.
Okay, the next part is conclusion. The result of the isolation of steroid compounds from the Hydrilla verticillata point using the mensuration method. There is a class of steroid compounds marked in green on the test tube when a phytochemical test is carried out, supported by data when separating using TLC, namely that there is one suspected steroid compound found in green spot 16, and the other 18 are suspected triterpenoid compounds. Isolation of steroid compounds using methanol solvent mensuration extraction produced a yield of 5.14%, and while the yield of an hexane partition resulted in a yield of 47.95%. And the identification result of the steroid compound Hydrilla verticillata isolate repeats, so that the absorption was at the equivalent of 276 nanometers and at 249 nanometers, so that there was no conjugate C11C. The result of identification of Hydrilla verticillata steroid compound isolate by FTIR showed the presence of OA, CH3 striking, CH2, A cyclic functional group, C11C, C11O, and C11O for esters, COC and C11O uptake for alcohol secondary, and chemical geminal group absorption, which is a typical absorption of steroid compounds. Identification result of the steroid compounds Hydrilla verticillata isolate with LCNS or MS produced mass spectra with N4Z of the precursor ion of 397 and N4Z of production of 161, indicating that percent of a steroid compound type beta-cytosterol. Closing suggestion. Future studies are expected to carry out further identification using HNML and CNML. And this is the reference. That is all for us. Thank you so much for listening and attention. We would like to apologize if there is a mistake. Wassalamualaikum warahmatullahi wabarakatuh.